Hello everyone. Welcome to my video presentation on focal point identification using golden section search. My name is Madhav with roll number 620224, currently pursuing in third year BTech in National Institute of Technology, Andhra Pradesh. I am presenting this as a part of the project course Optimization Techniques. The objective is to find the focal point of an image based on the color contrast. The focal points are areas of an image that draw the viewer's attention, and they can be used to guide the viewer's eye towards the main subject of the image. The goal of this project is to develop a Python script that can automatically identify the focal points in an image and mark them with circles of different colors based on their position. In this video presentation, we will explore the golden section search algorithm, its Python code with a numerical example. And then we will briefly discuss about the concept of focal point, which is a visual element that captures the viewer's attention and draws their eye towards it. Finally, there will be a code that finds the focal point of an image based on its color composition using golden section search in Python. So let's begin with an explanation of golden section search concept and golden ratio. Golden section search is a numerical optimization technique that is used to find the minimum or maximum of a function in a given interval. The algorithm uses the golden ratio to divide the interval into two subintervals. This process is a slow process, but it's very robust one. It has a good convergence rate. Before we dive deeper into the algorithm, let's take a moment to understand the golden ratio. The golden ratio, also known as divine proportion, is a mathematical concept that has been used by architects for centuries. It is an irrational number, 1 plus root 5 by 2. It is approximately equal to 1.61803. Now that we have an understanding of the golden ratio, let's take a look at the golden section search algorithm. The algorithm involves many steps. The first step is to choose an initial interval a comma b that contains a minimum or maximum of a function. And then we divide in the next step, we will divide the interval into two subintervals with the help of golden ratio. Here rho is the golden ratio. Of, and then we will evaluate the functional values of two of these subintervals. And later we will again choose two subintervals based on the inequality between these functional values. We will repeat this process until the interval becomes sufficiently small. When the interval becomes small enough, the algorithm stops, and the value of the variable at the midpoint of the final interval is considered as the optimal solution of the problem. Here is a Python code that automatically gives the optimal value once you give it a function to optimize it in specified interval. Here we are giving the function x squared by 10 minus sine x as the input to the previous Python code. Then the Python code will give us an optimum value by iterating through this step. After many iterations, the code will give us an optimal value of minus 0.7452 at the value of x equals 1.3064. And there are many wide variety of applications. Some of them include function optimization, design optimization, resource allocation, signal processing, and machine learning. It can be used to efficiently find the optimal solution for a given problem in these fields. It is also used for finding the optimal learning rate for a deep learning model. The learning rate is a hyperparameter that determines how quickly the model should adjust its weight during training. So let's trace the position of the focal point using golden section search. Before that, let's define the let's know what is a focal point. A focal point refers to the area or a point in an image, design, or composition that captures the viewer's attention and draws their eye towards it. In this presentation, we will find the focal point based on the color composition. You can see in this image, this part of image is the focal point. Focal point are commonly used in art, photography, graphic design, and interior design to create visual interest and emphasize important elements. They can be used to guide the viewer's eye, create a sense of balance, and convey meaning or emotion. In this particular image, this flower is at the focal point. There are many use cases of the focal point. Some of them include object recognition. In object recognition tasks, identifying the focal point of an image can help distinguish between objects. For instance, if the focal point is on a person's face in a group photo, a CNN model can be trained to recognize the individual faces based on their positions relative to the focal point. This can also help to improve the accuracy of object recognition, especially for images with multiple objects by giving the model a reference point to compare to. And in image classification, the focal point can be used as a feature for image classification tasks, which involves categorizing images based on their content. By measuring the distance between the focal point and different objects in an image, we can create a feature vector that captures the relative positions of objects. This feature vector can be used to train machine learning models for image classification tasks such as identifying different types of animals in an image. And in image segmentation involves dividing an image into different regions based on their content. The focal point can be used as starting point for image segmentation algorithms. This can be useful for tasks such as identifying the center of an object in an image. Now, this is the code to trace the focal point from an image. First, we will define the golden section search after importing the necessary libraries. We are importing CV2 library and NumPy library. This part of code loads an image and resizes it to a maximum of 512 pixels while maintaining its aspect ratio. If the height is greater than the width, the image is scaled based on height. Otherwise, it is scaled based on the width. And then we will define a function to compute the color composition at a point in the image. This function takes three arguments x, y, and size. This function computes the color composition at a given point x, comma y by extracting a region of interest of given size around the point and then computing the mean value of blue channel values in the region of interest. The function first calculates the top left and top bottom right coordinates of the region of interest based on the input point x, comma y. It then checks if the computed coordinates are within the image boundaries to avoid going out of bounds. If any coordinate is out of bound, it adjusts it to be within the image bounds. The function then extracts the region of interest from the image using NumPy array slicing and checks if the region of interest is none. If it is none, it returns 0 to indicate that no color was found at the specified point. Finally, the function splits the region of interest into three color channels: blue, green, and red. using OpenCV's CV2.split function and computes the mean of blue channel values using NumPy's np.mean function. The mean blue channel value is returned as a color composition at the specified point x, y. Overall, this function is used to compute the color composition at a point in an image, which is then used to find the focal point of image using search section algorithm. This part of code finds the focal point of image using golden section search algorithm. The y-coordinate of the image is iterated through with the steps of 50, and for each y-coordinate, the optimal x-coordinate is determined using the golden section search algorithm. The color composition at each point is computed using color composition at point function, which was discussed in previous slide, which takes x and y coordinates and returns the mean value of the blue channel in a region around that point. Once the x and y coordinates of the focal points are determined, a color map is created to assign colors to x coordinate based on their position relative to the focal point. Then circles are drawn at each focal point using cv2.circle function. The color of each circle is determined by the assigned color map. Finally, the image with the focal point is displayed using pld.image_show. And here the x point will be iterated with the steps of 50, and optimal y coordinate is determined using golden section search. And we will get the optimal y values using this. After getting the optimal y values, this part of code will draw circles at those y coordinates. And at the finally, the resulting image with the focal point is displayed using this cv2.imshow function. The window is closed when a key is pressed using cv2.wait key and cv2.destroy all windows function. And these are the results obtained when we give an image as input to this code. You can see there are different many circles with different colors in this image. Here each color indicate each focal point. If there are many focal points clustered, then it indicate a strong focal point. You can see that these flowers here indicate the focal point, and each circle indicate a focal point. These are the different images which are given as input, and in output. So why are we using golden section search for to get optimal values? Even we have many other optimization methods. We're using golden section search because of its simplicity, robustness, and many other advantages. The convergence rate is higher compared to other algorithms, and it is very memory efficient. It requires only small amount of memory, and it's very flexible. Using golden section search, we definitely get a solution, and there is no requirement of finding a derivative. Hence, golden section search is preferred among all optimization techniques in finding the focal point of an image. These are the references I use it to do this project. And thanks for listening. Have a nice day.